In our recent videos, we've been talking about resolving the resultant vector. So today we're going to be given this question that involves the direction of the resultant vector. Okay, so here you are given a boat which travels 90 meters due to the east and then moves 50 meters due north. Determine the displacement. Okay, so let's get this thing right first. Displacement and resultant is the very same thing. So if they say determine the displacement, they want you to determine the resultant vector. So here, let us start by drawing our vector diagram. So first of all, we are having 90 meters to the east. So here, this is 90 meters east. So this is our first vector. And then it moves 50 meters due to the north. So here, this is 50 meters north. Okay, so remember that we said if we have got vectors in a sequence of vectors following each other, then we use the tail to head method, whereby the resultant is from the tail of the first vector to the head of the last vector. So this is your resultant. So this is known as a vector diagram. So you can see that here this moves. Let's just make a compass here. We've got east, we have got west, we have got north, and we have got south. So this thing actually moved to the east and then up to the north. So remember that here each is always 90 degrees. So from north to east is always 90 degrees. So here it moved from east to north. Therefore, it means that we've got 90 degrees. Therefore, as you can see here, we've completed a right angle triangle. So in mathematics, when we have got a right angle triangle, we are allowed to apply trigonometry to be able to find many things: angles, sides, and lines. So here we have a resultant as a side. So the resultant as a side will be our hypotenuse, and then this will be our x side, and then this will be our y side. X represents the horizontal, y represents the vertical side. So here we can apply the Pythagoras theorem, whereby we can say the square of the hypotenuse is equals to the sum of the squares of the other two sides. So here you are trying to find your hypotenuse. Remember, your hypotenuse is the resultant vector. So you can just write R here for the resultant vector. So if you calculate that, that will give you 102,96 meters. So it means this is the size of the resultant vector. So you have the size of your displacement. So now you have applied trigonometry. Now that you found the size, let's go for the direction. Remember that direction is very crucial. Since we're dealing with vectors, it means we must talk of magnitude and direction. Magnitude being this size, we have found one mark. Now we have to find the direction. How do you find direction in this case? If you notice that our resultant vector has got an angle theta with the x-axis. So remember to rewind to our videos when we explained how to describe the direction of the resultant vector. We talked about a bearing, compass representation, and graphical representation of the direction of vectors. So now we are going to resolve angle theta, as it is an angle relating the resultant to the horizontal or to the x part of the whole system. So here we're going to use tan of theta. Reason being, we do have the opposite and we have the adjacent side. When you say opposite, it means it's opposite to this angle, it's adjacent to this angle. You can use any other trigonometric ratios. You can actually use sine, you can use cos, because you've got all the sides. So here, we're going to use tan theta. So by using tan theta here, we're going to substitute the opposite side being 50 meters, and then the adjacent side being 90 meters. And then to be able to find theta, we can move that tan over there, and it becomes a negative tan or an arctan, 50 over 90. So to be able to find our angle theta there, we'd have found that the magnitude of theta is 29,05 degrees. So it means that this resultant is actually 29,05 degrees above the positive x-axis, or above the x-axis. But then here we are recommended to use a bearing to describe the direction of a resultant vector. So I recommend you to just put a line over here. So if you put a line over here, you know that your bearing always starts from north as your 0. It means that your protractor must be, its 0 must be at the north. So it means that you are talking about the angle all the way from here until here. So it means you are actually resolving this angle over the north theta. Theta can help you to find that angle, since you know that from north to east is actually a whole 90 degrees. So it means that's a 90 degrees. So here, so far you have got 29,05. You can subtract that from 90 degrees. So you can say, therefore, the bearing, we are talking about the bearing. Remember that the bearing deals with north as your 0 degrees. So the bearing would be equals to 90 degrees, 90 degrees being the whole of the quadrant from north to east, and then subtracting angle theta, which is 29,05 degrees. Therefore, you find that the bearing of this whole system is actually 60,95 degrees. So it means that this resultant is at 60,95 degrees, at a bearing of 60,95 degrees. So to conclude with your answer, you say, therefore, the displacement, remember that the displacement is what is asked in the question. So the displacement is equals to, remember a vector has got magnitude and direction. Let's look at the magnitude. The magnitude being the size of 102,96, we're going to write 102,96 meters at a bearing of 60,95 degrees. If you don't understand how to use a bearing, we recommend you to watch our video when we described the direction of a resultant vector. Link in the description. Thank you for watching. Don't forget to subscribe. Tell your friends to stay tuned.